Okay, so welcome everyone. Thank you for joining my session. I will be speaking a little bit about like Spring Boot in a polyglot cloud native world. Um, this is a complicated presentation, I would say. It's a completely new presentation that I've created probably yesterday and the day before. So bear with me. It's a complicated story. We will see how we can get through it. So let's get started. I'm not a big fan of the agenda kind of stuff because it actually spoils the ending, so I will just keep going. So my name is Mauricio Salatino. I'm at Salavo in Twitter. That's my avatar. Usually I use that instead of my public pictures. I've been running a blog for more than 15 years, and I'm trying new things in there now, so if you want to check it out, just salavo.com. I'm working for a company that's called Diagrid. We help people to run cloud-native applications in production using tools like Dapr and some other open source projects. And I've been involved with a bunch of open source projects in the cloud-native space. Dapr is one of them, Knative is another one, and a bunch of other things that are kind of like interesting to me. And contributing to these projects is kind of like what I do every day. I've been also writing a book that is titled Platform Engineering on Kubernetes. I will be talking a little bit about platforms today, but if you're interested in the book, that's the QR code that you can get and get 40% discount on the price. The book is not printed yet, but you can access to it and start reading it. So let me get started with a simple question, right? Like, how many Java developers do I have in the room? Okay. Time is running out. Okay. Let's get the results, because I don't trust what you said. So I would say that 80% of people here is like Java developers. And then we have some Flash developers and some Go developers as well. But now, just to be clear, again, we are like more, when we talk about cloud native architectures and applications, we are like more in a polyglot space. And I wanted to make sure that I can just show and compare some of these tools that I will be showing in this presentation with other tools in other ecosystems as well. Nice. How many people here have more than one application? Are you working on multiple applications? Okay, that's a very high number, right? So I would say that some people said one application. 70% or more said more than one application, which is nice. If we are building cloud-native applications, you are going to deal with multiple applications, not just a single thing. And if you don't have any apps, I'm not entirely sure what you are doing in this conference, but let's move on. Next thing, how many does your applications actually read data or write data? How many people here says that like your applications are actually writing to a database or to a bucket or to a file? Yeah, that's kind of like what applications do at the end of the day, right? So 70%, I would say that unless you're doing some crunching without like reading data, like just calculating numbers and some stuff, you will need to get data from somewhere. You are going to be writing data somewhere else to store your results, right? If you don't understand the question, well, that's a little bit concerning, but some people, it's fine. You might be doing something completely different. So if you are not writing or reading data, what other things are your applications doing? Are your applications consuming or emitting events, in an asynchronous way? How many people here have that kind of stuff? That's good. Yeah, again, like you see, 30%. That's pretty accurate, right? So 30% of the time, you need to interact with some other applications by emitting or consuming events. That's more like asynchronous, right? Like using tools like Kafka or RabbitMQ, message brokers, or even kind of like cloud provider-specific tools. If you are not emitting events, that's okay. Like you might have different scenarios where you don't actually need those kind of things. Last question, I promise. Does your application, if you have multiple applications, do they talk to each other, or they are all completely isolated? So how many people, talking to different applications, of course, right? Are you using REST? I would say most of the time is REST. If not, if you are more like on the high performance side of things, gRPC is another option. If you are using other protocol, that's fine as well. That's all right. If you don't understand the question again, I'm not entirely sure what kind of applications are you building. So now that we have the facts and the results after this, getting all the questions, we kind of have like some kind of like a mess. We have complex applications. They are emitting events. They are storing data in databases or files or buckets or a cloud service. And they are exchanging messages in a synchronous way. And they are talking to each other. These applications need to communicate, right? I would assume that this is kind of like what your applications are doing, mostly, depending on the business, right? But this is kind of like how it usually will look. No matter what we are doing, we need these kind of like same behaviors. And I think that the entire presentation just moves around this topic, right? How do we implement all these behaviors without being too tied to the specific of the application that we are building, and also the infrastructure that we have available to do all this stuff? So let's talk a little bit about Spring Boot, right? I wanted to talk a little bit about Spring Boot because, again, I haven't been presenting in the Java community for some time. So I wanted to just go a little bit into this before we start. So if you are creating a Spring Boot application, the next question that you will need to answer is, what kind of infrastructure do I have? What kind of database do I have? What kind of service do I want to consume? What kind of message broker do I need in order to actually build these distributed applications? And that's a question that, as a developer, I can answer. But at the end of the day, I will not be running these components, right? Like somebody else, somebody will be in charge of running that. And it's a completely different set of skills that you need to do that, right? Like to maintain these components running and fine-tune for your applications to work. So let's talk about data, right? Like if you want to store data with your Spring Boot applications, you have Spring Boot data. Perfect. Spring Boot data is basically a set of abstractions. You can choose between different abstractions, so it feels natural from a Spring Boot application to build applications that store data into relational databases, document databases, or key value stores, right? In this case, what I wanted to highlight here is that we are choosing a framework, Spring Boot, then we have an abstraction, and on top of that abstraction, we have clients or drivers that we will need to include in our application to communicate with these components. And this is what I've learned in the Spring community, since I was young, 10 years ago. You just choose the driver no matter what. I remember in my early days, you need to download the driver from a website and put it on the class pad. That was pretty hardcore. Now, Spring Boot will probably do all that for you, right? Depending on the Spring Boot version, you are going to get like the version for the abstraction for that specific Spring Boot version. And then by default, you are going to get like a PostgreSQL driver, for example, that will be enable you to connect to the running Postgre instance somewhere. Messaging, it's pretty much the same. I would assume that this is OK for the Spring Boot community, but for me, if I'm coming from a different community, I will get confused with all the abstraction layers. There are too many options here. I need to choose, and I need to choose wisely to know what I'm doing, right? So you have different ways of sending messages in an asynchronous way, but you have the same thing. You have abstractions that you will need to choose, and then depending on the abstraction, you will just choose the right client. And the client, again, needs to match to the version of the components that you are running in some way or another, right? If you're running RabbitMQ 3.4, you need to have the client that can connect to that version and work. And because we are building Spring Boot applications, we can know all the 12-factor advantages, right? When you create a Spring Boot application, by using environment variables, your application will be able to run in different environments and connect to different infrastructure, right? We will just set some different environment variables. We will enable our applications to connect, and we are happy, right? Most of the time. This, I would say, I'm happy when I can just parameterize my application and move it to different production environments, to different environments, right? But this is not also good in a way, because we have some strong relationships with the infrastructure that we're running, right? So if I have my application A consuming including a Redis client, in this case version 3.4.3, connecting to a Redis instance that is in version 3.4.x, it doesn't really matter, the minor version in there, is that going to work if I just switch to a different version of the client? Is my client there going to support this, this minor version as well? Or do I need to, every time that I update my Redis instance, do I need to update all my applications to make sure that my clients are compatible with that new version, right? If I need to update my applications at that point, the life cycle of the application, it's really tied to the infrastructure that we are running. And then we cannot enable the people that it's running our infrastructure components to be completely independent from updating the applications, because they will update the components and then our applications will break. Or we are going to need to redeploy all the applications and change all the applications, re-release and all that stuff. It gets a little bit even worse when you are more like in a polyglot space, right? So for now, we are talking a little bit about like applications and dependencies. There is a relationship there. There is like a coupling there that we might want to start breaking up. It gets a little bit worse when you add frameworks and when you go into, again, like the polyglot world, right? So if you have applications in Java and in Go, you will have different abstractions for different kind of connections. In this case, if you want to have some connections to Redis, you will choose a library to do that, and then you will have a client for Go. How do you guarantee that these two applications will have actually the same behavior when they are talking to that Redis instance? And they are writing data in the same way. having the same performance boundaries and that things will work as expected. If you think about Spring Boot and all the abstraction layers, we are pretty high, right? Like Spring Boot is doing some very smart things in there. So guaranteeing that a very advanced framework can do the same as just picking up the client and storing data into Redis, it's a little bit tricky. It's very difficult to say, yeah, I'm sure that these two applications are doing the same things and they are working kind of like in the same way. Because at the end of the day, people who is fine-tuning Redis or RabbitMQ or Kafka need to kind of like understand what the applications are doing, so these components works as expected for these applications. And because we are talking a little bit about like the polyglot approach here, I wanted to bring up the Kubernetes, the elephant in the room, right? Like how many people are using Kubernetes here? Okay, like that's using, right? Like, or have you tried it? Like let's say using on there every day. Okay, cool, yeah, that's a pretty good number. If you have tried it, that's pretty good as well, because I do believe that learning Kubernetes is a very good investment for like engineers, like individuals, right? But when you go into the corporates, or like companies or organizations, adopting Kubernetes is pretty hard. What we get by choosing Kubernetes is the idea that we can now deploy and run applications on top of any infrastructure that we want. And as developers or people interacting with Kubernetes, we get a unified API to deploy and run our workloads there, right? And we can do that across all cloud providers and even on-prem. We can create like installations of Kubernetes on-prem and then just deploy our applications using the same tools, using the same ecosystem, just get stuff up and running. It's really nice for me from the API point of view as well, the idea that you have access to an entire data center just using a declarative API. You can say deploy and run my application. Kubernetes will take care of understanding in which computers to run different containers and all that stuff. But it comes with a bunch of overhead, right? Like now we need to learn a lot of stuff. And so far, I would say that in the first 5 years of Kubernetes, it was all pushed to, if you are working on an organization that's saying, we are going to Kubernetes, you as a developer need to learn a lot of this stuff. Most of the time, going into the Kubernetes way, it brings a lot of advantages, right? And we cannot forget why we are adopting tools like Kubernetes, because I think that it's very important to keep us remembering why we are just going through all the pain of using these kind of tools. Most of the time when companies look into Kubernetes, it's all about delivering software more efficiently at large scale, right? We wanted to keep deploying our applications, have zero downtime, and reuse all that declarative power that the Kubernetes API provides. That's very good, but remember, at the end of the day, Kubernetes is all about like deploying and running on our workloads. We need a lot of other tools to actually be productive on top of this. Just Kubernetes is just the starting point. So if we talk a little bit about Spring Boot and Kubernetes, right? Like there are a bunch of tools, extensions that you can use to actually run your applications on Kubernetes. But as a developer, again, that it's coming new to the industry, right? Like and needs to learn all these things, it gets quite complicated. What I wanted to show you here, it's basically that, of course, you need to containerize your application, and then you need to write some YAML files so you can actually send to the Kubernetes API to actually run your containers. And then there are a bunch of caveats there that you need to go really, really deep into understanding. So what I had planned here for this first demo, it's pretty simple. So if you have used Kubernetes, you have seen this before, right? I've created like a very simple Spring Boot application that basically I copied from some like Thomas repository, which is basically a very simple REST application that connect to PostgreSQL, right? And it uses Spring Data here, just to Spring Data JDBC to create like a CRUD repository to store some data in SQL. It's pretty nice. The application is pretty simple. Let me show you something here. Let me find here. I have too many projects, too many examples to show, so bear with me while I find stuff. Can you read this in the back? Yeah? OK, cool. So Spring Boot application, pretty simple. We have some REST controller here that will give access to our customers, and then some endpoints exposing that. Simple stuff. Then we have a customer repository. This is one of the Spring Boot abstractions that will encapsulate all the writing SQL queries to the database, right? So we created this application. We don't actually need to write SQL to get data or write data into the database. That's pretty cool. There are some other projects in the Go community, for example, or even in the Node community that will do something like this. Spring Boot is pretty on the advanced side of the amount of stuff that it's doing. And the thing that I wanted to mention here is, again, as I mentioned before, we needed to include the driver here for PostgreSQL, right? So we need to make sure that we have that runtime dependency. So we are including a PostgreSQL client into our application. And this PostgreSQL client needs to be compatible with the version of PostgreSQL that we're running in different environments, right? And that's kind of like important, right? So in order to move this application and run this application into Kubernetes, what do we need to do? We need to create a container, right? You can do that by having a Docker file that basically will containerize this application. And it gets tricky from then on, right? So first of all, you need to create a container. Containers are not platform independent. So if I'm running in my Mac using ARM architecture, I need to make sure that I produce, a Docker container that it's AMD for running on the cloud. Or, I need to make sure that my cloud provider gives me some ARM machines to run this application. So that's the first thing. So the first thing that I wanted to do here is I wanted to build that container. You can use Spring Boot 3 now that uses build packs to create containers. But again, how much of the support do you have there for creating multiple platform containers? It's not that great. It's coming. It's not that great, right? So as you can see here, I'm in my Mac machine, but I need to actually set the platform for this container, right? And then after I created the container for the platform where I want to run this container, the next thing that I need to do is I need to push it to a registry, to a container registry. So if I'm running in a remote cluster, my remote cluster can fetch that image and actually run it, right? So this all takes time, and it feels that developers shouldn't be doing any of this, right? And I'm not going to share like solutions for this, but again, think about this, right? Like you don't want to put developers to write Docker files because it's complicated. You will see that I'm going to use a lot of network here, and that also takes time and resources. And then again, I will need to have a registry where I have the right credentials to push my containers. Because if I don't have that, I cannot run my containers into a cluster. So I just build that container. I will Docker push it. And you will see here, as soon as I hit push, you will see that it's around like 30 megs that I'm sending, right? Like 28 megs that are pushed. It's pretty fast because the connection is fast here. But now I have a container in a remote repository. That basically means that now, if I want to run my application in Kubernetes running on Google Cloud, I can just send a request to Google Cloud and run that. And for that, you go into creating YAML files, of course. So that's all the pain of writing YAML files for configuring your applications, right? So in this case, I'm using two Kubernetes concepts, deployments and services, to just deploy my application and to run it. Again, as a developer, you can learn all these things. It's really interesting. I think that my Kubernetes journey is pretty good. In general, like I've learned a lot of things. I learned how to architect my applications better to run on Kubernetes. And I got a lot. But again, for a company that needs to train 100 people on these technologies, it's pretty hard. So as you can see here, the only thing that I'm doing is I'm making sure that I'm referencing the right container that I want to run. And then I'm just parameterizing all these variables and values so my application can connect to a PostgreSQL instance that it's running inside my Kubernetes cluster, right? So it's actually setting some environment variables. As we mentioned before, this is kind of like on the 12-factor side of things. You can connect to a remote database. This is pretty good, and I can do apply, right, like config here, and that's going to basically deploy my application. It was deployed before, I think, so it should be up and running. The problem that I have with my application now, it's actually running on the cluster. So I need to route traffic to the cluster in order to access it and test it in some way, right? Usually, before doing, like, you are not going to test in the environment, you are going to test it locally. And that's why tools like test containers can help you a lot, right? I can actually define some tests that are going to bootstrap an instance of PostgreSQL using containers, and then I will enable my tests to connect to that instance, right? And how do you do that? You basically create a configuration, and you add test containers to your project, of course. And in this case, I'm telling Spring Boot to bootstrap a new instance of test container the Postgre container for my test that my application can connect, send some data, store data, and then just check that everything is reading in there. So if you take a look at the test, I can share the link later on. It's pretty simple. And one nice thing about like Spring 3.1 is that you can actually run an application in that mode with test containers. So instead of like, if I start like the application using MBN, a Spring Boot start, right? A Spring Boot run, sorry, what's that? Spring Boot run will actually fail because I do not have any instance of PostgreSQL running locally, right? But what I can do now with 3.1 is I can do test run, and I can use the test container configuration to bootstrap a new instance of PostgreSQL so my application can connect. And I can actually start interacting with my application while I'm developing it. Right? So now I have a container that was created for my application. It's running locally, or it's running on the test container cloud, and my application is connecting to it. And this is, again, I'm showing all of this because I'm pretty sure that you're aware if you're using Spring Boot about all these things. But I wanted to show this because the demo will keep building up on these concepts, and it gets a little bit more complicated. So if I start calling the endpoints to that application, I need to make this bigger. If I call the endpoints, of course, that I will be able to talk to it, right? HTTP 8080 customers, that's the endpoint that I have. Of course, it's returning empty because I don't have any customer in there. But I can do a post, right? Post 8080 customers. And I think I have a customer JSON somewhere. And I've created like the Spring IO customer, right? And I can read it again. And that's going to an instance of PostgreSQL that is started by test containers, right? The nice thing about test containers is, again, that it's creating containers that are test scoped in the sense that they are being killed whenever like a new test starts. You can define the life cycle of these containers. So that's pretty cool. I think that that's a very good thing because if you're building cloud-native applications, you will need to do this a lot. You will depend on infrastructure. You don't want to install an instance of PostgreSQL in your laptop to test your application. Now you can do it with containers. That's pretty cool. Let's move forward because I think I'm way out of time. I'm going too slow. So let's go faster. Okay, so we have that. We have PostgreSQL. We still have that dependency of PostgreSQL in our application. And again, as a developer, I can deal with it, but we can make it better, I'm pretty sure. Going back to the Kubernetes side of things, you will notice that, again, when you're working with Kubernetes, you will need extra tools. Kubernetes is just the starting point. I've seen a lot of companies that started playing with Kubernetes, and then you realize that, OK, you need to build containers, you need to test containers, you need to check that the containers are working, you need to add policy to check which containers are working, you need to add security to your clusters. There's a bunch of other things. So if you go to any cloud-native Computing Foundation conference, you will see this diagram, which is kind of crazy. It's the amount of tools that you have in that space. It's mind-blowing, right? It's kind of like a lot. There are tons of projects. If you're using Kubernetes, you need to actually understand this diagram in a way, know how to navigate it, and know what to choose to use for your applications. So if you're in a Spring Boot application, in a Spring Boot conference, right? What tools do we need in order to be more efficient? That's something that you will need to answer at some point if you are going the Kubernetes route. That's why in these communities, there is kind of like a buzz around platform engineering, which is basically realizing that, OK, we need teams dedicated to understand all these projects, know what projects do we need to use, choose wisely, and then maintain all these projects so developers don't go crazy. Because if you put a developer to figure out all those tools, they are just going to spend time on just figuring out tools and not writing their applications. The idea of platform engineering goes all about that, like creating different, like a specific team that will take care of giving different teams, like developers or data scientists, the tools that they need to be more efficient building these cloud-native applications. And this is kind of like what we are talking about today. You will see a lot about like platform APIs, being self-service, creating golden paths to productions. This is not the presentation that I'm doing today, but you need to be aware of this. And there is a really nice paper that was published by the TagUp delivery, where basically they explain all these concepts and why these are important if you're building cloud-native applications. So if you haven't checked that out, please check it out. This is kind of like what's coming in those communities. I think it's important to share with the Spring Boot community as well. When we talk about building a platform for a company, I think that it only makes sense if you have a company that is large enough to have multiple development teams working on different parts of a large application. If you have these scenarios where you have tons of different teams working, what happens is that you need to start standardizing how do they work, and you need to have teams giving all these other teams the tools that they need to do that work. So when we talk about platform capabilities, we talk about like all these shared concerns that most of the services and most of the applications running inside these platforms are going to need. As we described before, right? Like when I asked the question, how many applications are storing and reading data, right? If I have 10 teams, I want all my teams to have an abstraction to say if I want to write data or read data from somewhere, I can use these functions, and I can use these methods or this library just to get stuff out. If I want to, for example, emit events or consume events, I want them to have the right tools for them to do that like nicely and not spend 2 months learning about Kafka or how to configure Kafka for the applications to work. And then you go a little bit up in the stack, right? Like you want to enable your developers to experiment. You want them to keep releasing new versions of the application and then in some way control which features are enabled using feature flags, for example. How many people are using feature flags in production today? Okay, you see, like there is like probably a 10%, and that should be kind of like what we do as developers every day. We should be build like applications and enable them like different features with feature flags. That's very, it's maturing a lot in the cloud native space, and I can see tools like Spring Boot getting more of that like soon by different providers. And then you have all the more like ops kind of stuff, right? Like you want to have metrics, you want to have resiliency for your applications, and again, you don't want your developers to be thinking too much about that. You want like a separate team making the right decisions, using the right tools for these things to be part of the platform. Stuff like release strategies, right? Like you want to do A/B testing, you want to do canary releases, so you enable development teams to release more software more often. And there are a bunch of tools in the cloud native space that do some of that stuff. I will be talking a little bit about Dapr, but Knative and Open Feature for feature flagging are kind of like one of the most common ones. How many people here knows about Knative, for example? It was mentioned a couple of times today, and I think that's good. Again, it's scaling down to 0, auto-scaling, and that's pretty interesting. How many people here have heard about Dapr before this presentation? Oh, that's really good. That's really good. Just to make sure that it's not me defining all these things and the CNCF side of things, you can see like these kind of articles of a company called Wix. I don't know how well known is Wix here in Spain, but Wix is a platform for building web applications like in a simple way, and it's pretty popular, and they have tons of users. And they have shared this article, which is pretty interesting, about how they built kind of like their own internal platform. They have, I think, 2,000 developers in the organization, and they are all building parts of the platform and the system. And what they have identified is kind of like the shared concerns across different services that they are building. So no matter which service you are building inside this platform, which has, I think that like around like 100 services, no, more than that, like 150 services, they all need this kind of stuff, right? Like they all need gRPC or REST to communicate with other services. They all need messaging. In this case, they are explicitly saying Kafka, so they have standardized on Kafka. They all need distributed tracing to figure out what's going on, custom metrics, security, authentication, health checks, feature toggles, right? Again, they are actually using feature flags and monitoring and all these things, right? So the larger the organization, the more teams that you have working creating software, the more standardization like this you need. And that's why I wanted to talk a little bit about this project Dapr, because Dapr is actually taking care of some of these things in a cloud-native way, but at the same time in a way that no matter which language you're using or which framework you're using, you can actually go and leverage this pretty easily. Okay, that's 30 minutes already. One big disclaimer, right? Dapr is not going to fix your relationship. It's not going to make things better with your wife or girlfriend or boyfriend. So it doesn't solve all your problems, right? Like it's a tool that you can use to do certain things. It's not going to do everything. So for the architects in the room, don't think that I'm saying that this is going to actually solve all the architectural problems that you have in your organization. What Dapr does, Dapr stands for Distributed Application Runtime, and what it does is basically it encodes a bunch of best practices, and it tries to give you some tools to implement all these distributed application components and patterns that you will need to build for your applications. So you can see here like the things that I mentioned at the beginning, right? Publish and subscribe messages, emit and consume events. State management, store a state from your application and read a state from your application. Service-to-service invocation, interact with other applications. And then you have all the things that are pretty common, like secret management, right? Like you need to read credentials from somewhere to you run your applications and connect to different services. Input and output bindings for connecting to external and even internal APIs, adding all the resiliency policies and all that stuff. Dapr, again, because it's a cloud-native project, you can install Dapr on Kubernetes. You can run Dapr outside of Kubernetes as well, and I will be showing some of that before at the end of the presentation. But in general, if you have a Kubernetes cluster, you can ask your administrator to say, OK, let's install Dapr in it. And Dapr works by extending your application with a bunch of local APIs that your applications can use. So if you have a Java application or a Go application, it doesn't really matter. When you deploy your application as a container to Kubernetes, what Dapr will do is will attach a sidecar to that application. So it will run another container, very small container, in the same context. And that container will expose a bunch of APIs. Those APIs are HTTP and gRPC APIs that your application can call to the local sidecar that is running there. So your application is not going to do like a network call. It's going to call a service that is running in the same context, right? For the Kubernetes people, that's a container running in the same pod. So it actually shares the same network namespace. So when you have your application writing HTTP and gRPC calls to the sidecar there is no major security risk, right? You're not calling a remote service. You're calling something that is running very, very close to your application. There is no latency as well. What this sidecar will do then is it's going to enable the application, let's say, operator or the architect to configure a bunch of Dapr components, right? So the sidecar can be configured to connect to the infrastructure that you need to use from your application. So for example, if you want to store data, you can create like one of the Dapr state store components to connect to a data store. Like it could be Redis. I will be using Redis for my presentation. But as soon as you configure how to connect to that data store, in this case, to connect to Redis, your sidecar will be actually in charge of pushing the information that the application is producing to that Redis instance without the need of adding a Redis client in your application code. So you are pushing the configuration and connection details of all the infrastructure to the Dapr side of things, to the infrastructure side. And you are letting your applications to talk a language that they know, HTTP or gRPC, without adding any extra dependencies. So the application that I wanted to show you now, it's not a very complex application, and it doesn't look that good, but it's composed by 4 different services, right? Like one front end, one application that is going to write data to Redis in this case, one application that is reading data from Redis, and one application that is subscribed to notifications about things that are happening. Again, we want to consume in an asynchronous way some messages. The way that this application works is by deploying this application into Kubernetes. There are 4 containers that will be running in there, and Dapr, because it's installed in that cluster, it's going to add all the sidecars to all these applications. The next step is to configure the components that we want to use, right? I want to emit messages from one service to the other, so I will configure the PubSub component that will be connecting to a piece of infrastructure to move messages around my applications. And I will be configuring the data, the state store component for storing data and reading data from Redis in this case. And by the way, do we have any Cassandra person in the room? That logo drives me crazy. Like that eye there, look at that. This is nuts. But yeah, love it. So the second demo is, again, I built 3 Spring Boot applications, all the backend services, write app, read app, and subscribe app, into Spring Boot. And again, what we will see here is that I've deployed all this application into Kubernetes, and we can access it somewhere here, right? So this is the application. It's a pretty simple application. This application is running on Google Cloud. It's actually on that public IP that you cannot read, so that's good. And I can say, hi, Spring Boot, Spring IO, let's say, right? And this basically is sending to the write service. This is reading it from the read service, so it's a separate service. And down here, I can just get the asynchronous notifications that I'm getting, right? So again, 3 different services and the front end interacting with these pieces of the application. And what I wanted to show you next is kind of like how is this running on Kubernetes, right? So I can list all the pods. You can see the application, backend services here, they are running. The front end is running. The application that is writing SQL is also running in there. And I have the instance of Postgres that my SQL application is using there as well. So the other thing that you can see here is that my containers, like my application containers, are also extended with the Dapr Sidecar. In this case, there are 3 containers, one 4K native that I'm using because I wanted to play with it. The other one is for Dapr, and the other one is my application container. The next thing, as I mentioned before, is configuring how Dapr is going to connect to these infrastructure components, and those are Dapr components. So I can get all the components from the Kubernetes APIs, and you will see that I have 2 different components, 2 different Dapr components. One is called state store, and the other one is called notification PubSub. So we can describe this, describe component state store, so you can see the configuration of this component. And I think that the important part here is this, right? So what I'm doing here is I'm telling Dapr that I have a state store component. I'm using the Redis, the state Redis implementation for this, and I'm giving my configuration for connecting to a specific Redis instance, right? Because this is Kubernetes land. This is not the land for developers, right? So somebody in charge of providing you a way to store data will need to go and configure this, and they will also need to configure the Redis instance that is running, right? They will need to fine-tune that instance so the application can use it and it actually performs correctly. You can see that I'm using Kubernetes secrets just to connect. It's pretty standard Kubernetes stuff. And the other component that I have is the PubSub component that it's also using notifications PubSub. Yeah, there you go. That it's a different kind of component. In this case, it's a messaging component, more like a message broker component. But it is also using Redis as the storage for moving around messages. That's not the best example that I can give. I can go now and replace this configuration for RabbitMQ or Kafka, and my application code will not change. My application code will say something like, I want to emit an event, or I want to consume an event. It will not need to change anything on the application code if I change this to RabbitMQ or Kafka. I think that this is the main advantage of using these kind of abstractions. If you take a look at the application code then, let's go to the right application code. Let's check the time. I have a bit of time still. So I have this right application, and you can see here that I am not importing any Redis client in the POM file, of course, either. I do not have any Redis dependency. But I am, let's say, cheating a bit, just a bit. I think that I have the Dapr client somewhere, right? Like I have this dependency here. I have the Dapr SDK for Spring Boot. This is extremely optional, right? Like I'm only including this Dapr client because I wanted to make my life as a developer a little bit easier, right? So I can do something like, Dapr client get state just to get the information out of the database. Again, the idea here is because I know my application kind of knows that it's going to be that it's going to have the Dapr Sidecar running besides the application, that it can actually do an HTTP call, right? I can use the web client, or I can use what was the name of the other framework, like the other classes to do, like the REST template, I guess. Like REST template just to do a plain HTTP call to a local API to get the values from the database, right? Again, my application doesn't have any Redis knowledge that this is running in Redis. And I can go and switch Redis for Cassandra or switch Redis for PostgreSQL or even for MongoDB. My application will not know. It will keep providing the same behaviors, and that's because Dapr is exposing this standardized API to store and read state. As you can see here, I'm getting a state, I'm saving a state, but I'm also publishing events. So I have another method that will allow me to send a message. And that message will be routed to all the applications that are listening for these events, right? So it's pretty simple. From the receiving side of the events, you just need to expose an HTTP endpoint. And then on the wiring, like the person that is wiring things together will need to create a subscription mechanism that we can see here. Get subscriptions, right? So I have a subscription. In this case, my subscription basically says that I'm interested in all notifications that are going to a specific PubSub component, and all the notifications that I'm getting there, I will route to my subscribe application in this case. So if I describe this, it's pretty simple syntax, and you can add more filters and stuff. Notifications, there you go. So in this case, what I'm doing here, again, this is the important part, is that my subscriber app will get notifications that we send to that notification PubSub component that I've created. So as soon as my write application is emitting an event and just aiming to that notification PubSub component, and the notifications topic in this case, we will get notifications being routed to the subscriber app into the notifications endpoint. So as soon as the application exposes that endpoint to receive notifications, we can route notifications to it. And that's kind of like how the application that I've showed here is getting the notification in this case, right? Again, the whole idea here is we have a standardized API that our applications, in this case Spring Boot applications, can use in order to interact with all these infrastructural components without knowing which those are. Like, which are those, right? Like, can be Rabbit, can be Kafka. The application doesn't have any dependency. We just separated a bit the infrastructure from the application code. That was the point of the second demo. And I think that it's an important point also to make, right? Again, as I mentioned before, Dapr is not going to solve all your problems. So if you actually want to do some, for example, very specific PostgreSQL things, right? Like you want to do, very high-performant PostgreSQL queries, and you want to actually go and use the Postgre advanced features, you can actually create your Spring Boot application, use the PostgreSQL driver, do all those specific things in a separated service, enable that service with Dapr so all the other services can interact with it in a simpler way, and isolate the rest of the applications, all the other 95% of your applications that are doing like normal operations against databases or message brokers or secret stores, and enable those applications to be more decoupled from all the infrastructure that they need. Dapr is pushing really hard to have all the APIs of these components like standard, right? Like there are some other communities that are building similar APIs, and we are trying to standardize and unify those APIs so they are not like the Dapr APIs, but more like the application level APIs that every developer can use. And then that we are using Dapr to implement those APIs is just a detail, right? It's not a mandatory thing. So just to go back to that kind of like platform article that I mentioned before, when we look into what Dapr is providing nowadays, it's actually focused on all these topics, all these shared concerns that applications have. Dapr has like a component to solve that. I'm working on a feature flag, component as well that's coming in a couple of months. And then if you use tools like, for example, Knative for release strategies, A/B testing, or headers like HTTP headers routing and cookies, you can actually start building this platform that is taking care of all these concerns for developers. So you enable developers to focus on coding, and you enable developers to keep releasing code without being tied to the components that they are using for the infrastructure. But you might be thinking at this point, and I think that I have 9 minutes to do this last demo. I'm a developer. I don't have a Kubernetes cluster, and I'm not so used to work with Kubernetes. Can I actually use Dapr to build my applications and connect my applications in my laptop, in my local environment? And the answer is yes, because we love test containers, and we have been working with the test container folks to create some integrations to enable Spring Boot developers, and also soon Go developers as well, to build all this stuff locally in their laptop. So the idea here, it's the same, right? Imagine that you're building these multiple applications, and you want them to talk to each other, but you don't want to run them in Kubernetes so they all run, and you don't want to rely on Kubernetes to inject all the Dapr configurations and all that stuff. So you can actually do that today with test containers by using some extensions. And the idea here is that whenever you start your write application, for example, test containers will bootstrap a Dapr Sidecar that will run close to your application and all the infrastructural components that you need for that application to work. The next question that you will have is that, okay, if I run my write application and it starts all that stuff, and if I run my read application and start all that stuff, then now I have duplicated infrastructure, so my services will not be able to talk to each other. We have built that as well, and we have some people from test containers that help me do all that crazy stuff. So now, actually, what I wanted to show in the third demo is that I can start 3 different Spring Boot applications. They can all share the same infrastructure. They can talk to each other, and again, without including any library to interact with Redis or RabbitMQ or whatever we want to use there. So the third demo goes like this. I have the source code of these applications, like the write application. It's the same source code that I deployed into Kubernetes, right? But again, if I want to run it locally, I want to make sure that it's running pretty close to what is happening in Kubernetes. So I want to make sure that Dapr gets started when I run this. For that, I'm using Spring Boot, again, 3.1, that actually allow me to do the test runs here. I like test run. Again, using test containers and the test container configuration. So when I run this for the write application, if the network works, you will see that a bunch of containers are going to get started, right? Like it's being pulled and started. So now my application, when it starts, it's going to actually connect to a Dapr instance that it's being created for my application. And I, as a developer, I actually don't need to do anything. So we are trying to build this common functionality for your Spring Boot applications. You add a dependency, and then you have this behavior, right? Because my application is now started, as I did with the PostgreSQL example at the beginning, I have a Redis instance that my application can connect, but I'm not connecting from my application, I'm connecting through Dapr, right? And that's also included in the test container integration, which basically allows me to say, okay, my write app in the test resources components folder, I have my PubSub configuration and my state store configuration, right? My write app is going to save state and also emit some notifications, so I need some infrastructure to be configured for it. And that's basically being bootstrapped there. So now, again, I can actually go and interact with my right application. But before doing that, I wanted to start all the services. So let's do nbn Spring Boot test run. And the same on the subscriber side of things. So nbn Spring Boot test run. These applications, of course, because they are running locally, will need to interact with the containers that this test containers is creating, right? So there is a lot of making sure that my application, that it's a running process in my laptop, can connect with these containers, but also that the containers that are running can connect back to my application, right? Imagine the case where I want to emit an event from one application to the other. It needs to go through Dapr, and Dapr will need to call back my application just to be able to receive that event. And that's a lot of network kind of like configuration and wiring things up. That it's pretty good that you as a developer shouldn't worry when you're doing these things. So I have my 3 services up and running. You can see that because I'm running my services locally, these services will need to all run in different ports, of course, right? But that's part of the test configuration, right? So I have one in 8080, the other one in 8081, and the other one in 8082. As soon as I have that up and running, I can actually start interacting with the APIs. So I can do HTTP, the same things that I did before. Post, I say this is 8081, I think. Message. So I'm basically replicating the same thing that I did from the user interface, but now I'm just doing against my services that are running locally, not the ones that are running in the cloud. And the infrastructure that I'm using is the infrastructure that was created by test containers, not the infrastructure that is running in my Kubernetes cluster. So I've sent a write message hello to the right application. I can actually think that I can check from the read application that the message is stored. Let's see. Yep, it's there. And I can also check in the subscription logs here that I received a message in an asynchronous way, right? So now I connected 3 applications without connecting to the real infrastructure. I'm going through Dapr configuration. Test container is bootstrapping all the infrastructure plus all the Dapr wiring. And my Spring Boot applications that are running locally can connect to all these things, again, without having any dependency. I think that that's pretty, it's a pretty interesting approach. Again, it's not going to solve all your problems, but it's good to know that tools like this exist if you are building cloud-native applications. One more thing that I wanted to do to just highlight like that crazy thing that I showed here with the with the SQL side of things. If you are doing SQL, it's fine. What I did is I enabled my SQL application to have Dapr in it. So what I can do now is the only piece of the presentation that it has some Go code is I'm going to change my HTML front end here that I have it somewhere here. I'm going to change that front end to actually call that service and have it integrated in my application, right? So I can actually do that. So what I need to change here is just the call for my application. I have a button here that is in charge of calling that SQL service that I deployed before. And I can update this application. And again, just to show a little bit of polyglotism here. And I'm using a different tool for Go. Of course, I do not have Maven or Spring Boot there. So fconfig. And same thing, right? Like no matter if I'm in Go, on Spring Boot, or in Java, or any other language, I will need to build the changes, I will need to publish a container image, and I will need to deploy it to the cluster. In Go, you do this with Go, which is, again, it will just resolve everything, deploy and push all my configuration files to the cluster. If I go to the cluster, because, again, I'm using Knative to expose my application, I should be able to refresh here. And at some point, I should have the new version up and running. There you go. So we have the new version. And I have this new SQL button here that I can click. And yep, I can get my customer, Spring IO customer from the SQL database. Again, what I wanted to highlight here is that now I'm interacting with that thing that it's using the PostgreSQL driver, that it's very specific and it is using it for a very good reason. Interacting using service-to-service communication in Dapr that allowed my application that it's reading in Spring Boot to just do an HTTP call to interact with this other application using the REST endpoints, right? So pretty easy, pretty fast to integrate. And again, it's all running there, and it kind of works. The main idea of this example is also to create a tutorial that you can just run in your own laptops if you're interested in so. So please feel free to reach out if you wanted to give it a try or if you have any feedback about these things. I know that this presentation, is kind of like a lot, and it covers a bunch of things. But the main takeaways that I want you to take from this session are that, having the right abstractions for your developers to go faster is really important if you have a large organization with different teams building different parts of the system. If you are going full on Kubernetes, looking in tools like Dapr, it might be a good thing to know at least. The idea of breaking dependencies from the infrastructure, I think that it's really important, and it's becoming really, really relevant in the cloud-native space. And I do expect to see more tools doing this kind of stuff. Again, as I mentioned before, there are more communities building these kind of abstractions, and I think that that's a pretty important subject. Dapr works with any language because, again, it exposes HTTP and gRPC endpoints. That basically means that no matter which language you're using, Python, Node, or whatever, as soon as you can write an HTTP request, you can actually interact with Dapr and with all the components that Dapr provides. And finally, test containers. I think that it's doing a great job on allowing me to use all these cloud-native concepts that requires multiple containers to be bootstrapped and wired up together and configured to work with my local development flow. Right? Like, I use the Spring Boot, start all these things, and then it feels like my application will behave in the same way that it's behaving inside Kubernetes. So thank you very much. That was my presentation. 1 minute over time. I will leave it to the to the book. I need to do some advertising for that. Thank you very much.